Fresh from the sea, the desalination process. Article: Fresh from the sea, the desalination process. Introduction: 150 words. The scarcity of fresh water has become an increasing concern worldwide. As our population grows and climate change affects our environment, the demand for clean water continues to rise. In areas where freshwater sources are limited, desalination is emerging as a solution to meet these growing demands. Desalination is the process of extracting salts and other impurities from seawater, making it safe for human consumption and various other uses. This article will delve into the desalination process, exploring the different techniques used, its benefits and potential drawbacks. Desalination techniques, 350 words. Desalination can be achieved through various techniques, but two methods are most commonly used: reverse osmosis and distillation. Reverse osmosis involves forcing seawater through a semi-permeable membrane that filters out the salts and impurities, producing fresh water on the other side. This process requires substantial pressure to overcome osmotic pressure, ensuring successful desalination. Distillation, on the other hand, involves heating seawater to create steam. The steam is then condensed, leaving behind the salts and impurities and providing fresh water. Both techniques have their advantages and disadvantages, and determining the most suitable method depends on various factors such as energy availability, infrastructure, and cost considerations. Benefits of desalination, 400 words. Desalination offers several significant benefits, particularly in regions where fresh water is scarce. First and foremost, desalination provides a reliable and sustainable water source that is not dependent on unpredictable weather patterns or limited underground aquifers. Desalination also helps mitigate the impact of over-extraction of groundwater, preserving these precious resources for future generations. Another advantage of desalination is its positive impact on agriculture. With fresh water being a primary requirement for successful crop growth, desalinated water can be used for irrigation, enabling cultivation in areas previously unsuitable for agriculture. This not only boosts food production but also helps stimulate economic growth and improve food security. Desalination also plays a vital role in industrial processes, providing a consistent and high-quality water source for manufacturing, energy production, and other industries. By utilizing desalinated water, industries can reduce their reliance on freshwater sources and minimize the environmental impact associated with their operations. Drawbacks and potential solutions, 400 words. While desalination offers various benefits, it also presents unique challenges and drawbacks. One major concern is the high energy requirement for desalination, making it an energy-intensive process. This increased energy demand leads to higher operational costs and carbon emissions. However, advancements in technology and the adoption of renewable energy sources can help mitigate these concerns. Integrating solar, wind, or tidal power into desalination plants can not only reduce their carbon footprint but also make the process more sustainable in the long run. Another challenge is the disposal of brine, a byproduct of desalination that contains concentrated salts and other minerals. Discharging brine back into the ocean can harm marine ecosystems due to its high salinity. One solution being explored is to utilize the brine for other purposes, such as salt production or even renewable energy generation. Research and development efforts are ongoing to find innovative ways to minimize the environmental impact of brine disposal. Sure. Here's the continuation of the article. Methods of desalination, 400 words. There are several methods of desalination, each with its own advantages and disadvantages. One common method is reverse osmosis, in which seawater is forced through a semi-permeable membrane to separate the salts and impurities from the water. Reverse osmosis is widely used due to its efficiency and relatively low cost. Another method is multi-stage flash distillation, which involves heating the seawater and then condensing the vapor to obtain fresh water. Although this method has higher energy requirements, it can produce large quantities of fresh water. Electrodialysis is another technique that uses an electric current to separate the dissolved ions from the water. This method is less energy intensive compared to reverse osmosis but requires frequent cleaning and maintenance. Another promising method is forward osmosis, which uses a draw solution to extract water from the seawater. This method has the potential to be more energy efficient, but further research is still needed to optimize its performance. The choice of desalination method depends on various factors such as the salinity of the seawater, available energy sources, and the desired quantity of fresh water. Desalination plants are often designed and built with a combination of these methods to maximize efficiency and reduce costs. Future outlook and adoption, 100 words. The demand for fresh water is expected to continue increasing due to population growth, urbanization, and climate change. Desalination offers a viable solution to meet these growing water demands. With advancements in technology, the cost of desalination has been decreasing, making it more economically feasible for many regions. Governments and organizations around the world are investing in desalination infrastructure to secure their water supply. Nevertheless, it is important to strike a balance between desalination and other water management strategies to ensure long-term sustainability. Sure. Here's the last part of the article. Environmental impact and challenges, 250 words. While desalination provides a solution to freshwater scarcity, it is not without its environmental impact and challenges. One significant concern is the disposal of the concentrated brine, which contains high concentrations of salt and other minerals. If not properly managed, the discharge of brine can harm marine ecosystems and affect the overall balance of the ocean. To mitigate this impact, several strategies are being explored, including diluting the brine before discharge and using it for industrial purposes such as salt production. Energy consumption is another challenge associated with desalination. Most desalination methods require a significant amount of energy, predominantly from fossil fuel sources, contributing to greenhouse gas emissions and climate change. However, the integration of renewable energy sources such as solar and wind power can help reduce the carbon footprint of desalination plants. Research and development efforts are ongoing to improve energy efficiency and explore alternative energy sources for desalination. Cost is also a factor that influences the widespread adoption of desalination. While the cost of desalination has been decreasing, it is still relatively expensive compared to traditional water sources.